Hello, my name is Yang Li. I'm the AP teacher here, and today we're going to continue our lecture about the example 3.14. This section, we're talking about continuity and the differentiation, right? Derivatives, right? So remember we learned before, if a function is continuous but not guaranteed differentiable, but if it's differentiable, then must be continuous, okay? So right now they have an application about this one. We try to work on this one first. They said a toy company wants to design a track for the toy car that starts along the parabolic curve and then converts to a straight line, right? The function is like this. The top part is a polynomial. That's a parabola, quadratic. It's like a trinomial here. And this one is a linear, right? And to make sure the car is smooth along the track, the function must be both continuous and differentiable at x equals -10. You see here, this function we call it as a piecewise function. Less than -10 is this. And after the -10 belongs to this, okay? But right now, we need to determine what's the A and the B. So for this one here, we can build up the equation first, okay? First thing, we use this condition, they said the continuous. If it's continuous, it should have what? The left limits equals the right limits and the equals to the value of the function. Remember that? So let's find the left limit first, okay? Left limits x approach to, oh, I just followed the book. They have this one here already. I don't need to write it down. I can show you here. You see here? They make the left limit equals what? The value of the function. Left limit, plug in, you just plug in x by -10, right? Here. This is the x by -10. So you will get this part here. And f -10, just plug in -10 inside also. You will get this, right? So from here, you can see that if you simplify this equation, you will get this one. You will get this part. And then from here, you can get what? C equals this one. We build up the first equation about the C, okay? This time, we're using the left limit equals to the value of the function. We can get this one, all right? And the other one, we do what? Derivative at x equals 10. Be careful here, okay? Derivative of x to 10 because they have what? Fx minus f -10. No problem with that. Divided by x plus 10. Actually, this is the x minus -10, right? That's the definition of derivatives. No problem with that. And then after this one here, and we can do is, because the left and right equal, right? This one, derivative means you have a left limit, you have the right limits. So be careful here. This is called the left limits because x approach to -10 from left side at that x equals -10 there, right? And this one we simplify, okay? So fx will be this one and the minus f -10. F -10 we knew is 5. Like this. You plug it in, you can calculate it, right? And then, because here you have a B and a C there, see that? So what we need to do is plug in this one C in terms of the edge, put it to here. So you're gonna have limits, x approach to -10 from the left side, it will be equals to this one. Because just plug it in. And then the rest of the work simply simplify. How do you simplify this one? You simply time this one by 10. Of course, you got time the denominator by 10. So 10 times this one, you got an x squared. And this one times, you see here, this one times this one will be 100 bx, that's this part. And this one times this one is 100b, that's this part. You got this part. But only this part here. -5 minus -5 to -10. -10 times by 100, I put it here like this, right? But why they go this way? They switch around. Of course, it's available, right? Because the community property of addition is true. But they want to do, I'm showing you this part, okay? I'm showing you to this part for the detail steps. How do you get from here to here? So this part here, you can see x squared minus 100 is 10 squared, right? And then you plus this one here, you can take 10b out first, common factor for this group. Common factor is 10b. So you put what? 10b here. After you take the 10b out, you will have x. And then plus 10b, so you have 10 left over, right? This part. Continue. This part use difference of two squares. We use this formula for many, many times already. This one equals to x plus 10 and x minus 10. And the plus, this is 10b, x plus 10, like this. Do you notice that? This x plus 10, this is the common factor, greatest common factor, take it out. So that's why they take out here. So after you take it out, x plus 10 out, here left is x minus 10. And then here should be plus 10b, like this. You see, they got this one times this one, same as this. Now, you see here, you can cancel this one. Because x equals approach to -10, -10 plus 10 is 0. Denominator equals 0, that's not good, right? So you have to cancel first. And then you plug in, okay? You plug in here, this is a -10, -10 next 20. So this part you can have what? -20 plus 10b over 10. So that's this one divided by this one is -2. This one divided by this one is b. So that's why you have the left limit equals this one, right? Now we're going to continue build up equation because we knew this one must be equals what? Because it's differentiable, right? So it should be equals to the right limits, right? Right limits, be careful here. The function is different from very beginning, you can see here. The function should be -1/4 x plus 5/2. That's 1x on the right side of -10, right? So based on this, what we're gonna do is here, right limit differentiation, right differentiation at x equals -10 will be f still equals to f x minus f -10 over x minus -10. And then this is the fx. F -10 will be -5. So -5 like that. And then go this one, right? And then you're going to simplify, okay? Let's simplify this now. So we're gonna go this one. We try to time the least common multiple or least common denominator of the 4 and the 2. I time by 4 here. I time by 4 here like this. So when you got this one times this one, you will get -x, right? This one times this one, you're gonna have plus 10 like this, right? And then this part, you can continue change it to it. Take the negative out. You can be careful here. This one. Oh, wait a minute, hold on. This one's this. When you have this one time this one is negative x, this one time this one will be plus 10. And this one time this one will be negative 20. So this part will be equals to negative x minus 10. You can factor the negative out. You're going to have x plus 10 like this. The bottom one, just this one, which is a 4x plus 10. Cancel. So when x approaches 10, doesn't matter, just negative 1/4. Now, we knew this function must be differentiable at x equals negative 10. That means the left derivative, or this right derivative, should be same as the left derivative. So that means you have the equation b minus 2 equals to what? Negative 1/4. And then you add 4 both sides, you can get a b equals this one. So when you got a b equals this one, you can use what? This given condition. C equals 10 times b and minus 5, you can get this one. So as long as c equals 25/2 and b equals 7/4, the function, the piecewise function, this one, should be at x equal, should be always continuous and differentiable, even at x equals negative 10, right? So that to make this track smooth, okay? And we are going to use the same idea to explain the checkmark question of 3.8, okay? So, but what you can do is this. Before you watch my next video we're going to cover this one completely, detailed steps, okay? But at this moment, you may try by yourself before you watch the video there. And then you can check how much you can do by yourself, okay? So this lesson, this video, we just stopped it here. And if you have any questions, please email me, all right? Thank you. Bye-bye.